Hello fantastic people! Today we'll be doing something very special. Complete platform movement. It will have everything. Double jump, wall sliding, wall jumping, dashing, variable jump height and so on. So I hope you are excited. Before we start, I would love to ask you for a drop of your trust and liking this video. This will help spread it a little bit more and hopefully help larger number of people. Let's get straight to it. We'll be starting with this player object. This is something you should already have in your scene. It's very simple setup. You can actually set up any way it's convenient for you. So I do have a empty game object player. Then it has a child object called sprite, or rather sprites, and it holds both legs, body, and the head. As you see, the character is pretty simple. It doesn't have any arms. We won't need those. They would make the animations a little bit more complex and everything taking a little bit longer time. So first thing we have to do, of course, because we want to utilize physics for our platform movement, we need to add the rigid body 2D to our character. So let's do that first. Now, in the rigid body, the body type has to be set to dynamic because, of course, we want the physics to work on this particular object. Then we want the collision detection set to continuous, because if you have it set to discrete, it is a little bit more performant, but sometimes you may get weird artifacts. Sometimes the collisions are not that precise and things happen. Like, it shouldn't matter that much with the platform movement, but if something is moving crazy fast, what will happen, it can actually jump through another object and this type of stuff. So it's good practice for those critical objects that it is set to continuous. Then one of the most important thing, we have to set the freeze rotation in that axis. Let me show you what will happen if we don't do that. Hopefully, very important thing, I do have already a collider on my main tile set. So as you see, let's forget the renderers for now, they don't matter. We have the tile map collider with the composite operation set to merge. So basically what happens, maybe let me remove that, will be a little bit cleaner or clearer for you, hopefully. So I have this tile set, and of course, if I wouldn't have a collider on it, and the character doesn't have collider as well at this moment, but basically, for things to collide with each other, they need to have colliders. So for the tile map, I am setting first the tile map collider 2D, and let me enable gizmos. So you see every single cell is now a separate collider. So this is not that good for performance. So what we want to do, we want to add something called composite collider. I add the composite collider, and then I set the composite operation to merge. And as you see, suddenly it became one big collider instead of many small ones. Now, important thing here, we don't want the tile map to be affected by physics, so we simply change the body type to static. Now, of course, we need to go back to our player and we need to add a box collider to it as well. Box collider 2D, of course. Then we adjust size. Let me maybe move it a little bit higher. Something like that will do. And let me show you, at this moment we have the freeze rotation not disabled, or rather not constrained. So if I press play, hopefully, yes, you see the character rotates and falls, and this happens even when you walk and jump and stuff, and we don't want that to happen. And now if I freeze the rotation, that means the Z rotation cannot change unless I change it via script. And we see that this helps with this particular problem. Now it's time to write our first script, which will be the platform movement. I'm already in the scripts folder. I create new mono behavior script and call it platform movement. And now I attach it to our player object. Let's open it. We are using the new input system. This is very important. So we need some references to the input actions first. So let's now first add header, input references. And then let's put first one. For the input action reference, that's the type of the action that is used by the, if you want to drag and drop individual actions. And move action is actually the correct one, the one that we want to use. I didn't configure properly my auto formatter, so you will see sometimes strange stuff like the serialized field jumping around, and I will have to fix it manually. I hope it won't bother you too much. Then I import the input system, and this reference becomes available. So now we need our first actual reference to something related to movement, and that will, so let's create header for those, and that will be walk settings. We want a serialized field exactly for walk speed. Let's maybe do it something smaller, like 3 or maybe 4, and that will be all right. And now we have to react to the movement. So in the new input system, how it works, rather than, of course, you can do it also the continuous way it was done in the old input system, but this is not the kind of, done by design, or this is not the correct way to do that. Much better way, much more performant, cleaner is to use events. So let's do that now. First of all, we want a reference to the value that will be given by the action. So let's create one, vector2 move input. And now let's subscribe to the action. So private void on enable. Let's straight away add the disable, private void on disable. And now for the move action, so move action performed, we need to add new action, which will be handle walk input. For now it complains, but let's do one thing more. So because the input value changes also when the action is cancelled. So for example, if we use the WSAD keys, right, if you press S, it changes value to, let's say, 1. But when you release the key, the value is also changed, but this is not performed anymore. The action of taking your finger from the key is cancelled. So we have to subscribe to that as well. Otherwise, when you release the key, the input will not change. So cancelled, handle input walk. We take those ones, add them on disable, and here we change to minus to unsubscribe to the event. So the plus subscribes, minus unsubscribes. So in case you didn't work with events before, I have some videos. I will link them somewhere here at the top. Now we need a, because those events expect a method that will accept the input action callback context, exactly like this. So let me just change to this one. I prefer to have it a little bit shorter. And yes, everything seems to be correct. So we created a method, private handle walk input, which takes the context from the event and then uses this context to read the value of type vector2, because we use the WASD keys, right? So we have vector2 because we have horizontal and vertical input there. And then we store it in the move input. Now, of course, we have to do something with this input. So now in the private void update method, let's handle movement. Instead of doing that this way, let's maybe first grab the rigid body reference, because obviously we have to set this velocity somewhere. So private rigid body to the RB. Beautiful. Now, of course, we need this reference to be set, so we can do that in awake method. RB get component rigid body 2D. So of course, as you remember, on our objects, let's wait for it to recompile, we have different types of components. So get component, of course, grabs a component of a given type from the object and assigns it to the variable or field or property. So over here you see we have the property, or rather we have the field rigid body, and then we get the component of type rigid body 2D and set it. So we have access to that now. So in the update, instead of doing that directly, let's create a small method. So private void handle walking. And over here, what we can do, exactly that. RB velocity move input times walk speed. Is that correct? No, that's not what we want. We want the movement. That's the reason you have to be very careful with the autocomplete. So instead of doing that, let me just do RB, then linear velocity x. So because we want just the movement in x axis equals move input x times walk speed. This is the simplest way to add movement. Now we can call this method in update. And if I'm thinking correctly, that should be everything we need to have very simple movement in both directions. So nope, of course, I need also to assign the input action. In the main folder, if you have a look, if you created the project using one of the new versions of Unity, you will have some pre-configured input actions for you. So you can open it and you see you have multiple actions over here, and they have already some defined bindings. So for example, move can be done via WASD, left stick on the gamepad, and so on, so on. So let's use that. Let's do not save it in case I change something accidentally. On the player, on the platform movement script, we can simply grab the player move action and assign it here. And now it should work. Let's check it out. Beautiful. Whoa, that's a little bit quick, but for now it will do. So you see our movement in both directions works. And you see the rigid body physics already handles for us as well the physics. So the character falls down by the use of the gravity. So that's also perfect. Now, because the movement is very snappy, let's add a little bit of acceleration and deceleration to slow it down and not go directly from 0 to full speed, but smoothly transition from a 0 to nice movement speed. Let's do that now. So in the walk settings, let's add two serialized fields. First one will be called, let me think, acceleration. And let's do here something like 10, or maybe something smaller, just so you can see the effect nicely. And then another one, deceleration. Deceleration will be a little bit quicker. Okay, so we have acceleration and deceleration, and let's use them now in our handle walking. So this we can get rid of that completely. And now we have to decide which change value we would like to use. So let's create a variable for that. And now if our move input in X is not 0, so if we are actually pressing some buttons, then let's use the acceleration. However, if we don't move, or we don't have any buttons pressed, then let's use deceleration. Beautiful. Now we need to lerp between values. So lerp is interesting thing. Lerping is basically moving between two values. So you have value A and value B. Maybe let me write it down, that will be a little bit easier. And let's use a little bit different numbers. So let's say I have a number A, which is 0, and I have number B, which is 100. Then I have a factor, which can be anything between 1 to 0. So what lerp does, it takes this parameter, right, and it kind of transforms it to one of those numbers or something in between. So for 0, it gives you A, for 1, it gives you B, and for values in between, it gives you the value in between, right? So if I would say the F equals 0.5, then it would mean 50, right? It's this type of stuff. I hope it's clear. So we'll be doing a small trick. We'll be constantly changing A to make very smooth, nice transition. And for F, we'll be using delta time. So it will be like the change will be kind of consistent between frames, but on the other hand, it will be very smooth. You'll see what I mean. It's very nice effect. So over here, we want the, of course, set the linear velocity x, and that will be mathf lerp. Now we'll be starting x, right? So we will be starting from the value that we are currently moving at, so like the current velocity, and our target is move input x times walk speed. So this is the like full speed at which we want to be. And of course, this shouldn't be velocity. The autocomplete is killing me. Sorry, guys. This should be that. And then for the third one, it would be time delta time times change. So this is done in order to decide how fast the value will be changing. And the higher the change, the quicker it will be. So that's the reason we can now adjust the acceleration or deceleration, and then it will be changing accordingly. So we do have that, and I think this actually should be all we need. Let me have a look if it works. Yep, you see we start very. The character, you see the character is a little bit struggling with walking. That's not because of what we've done. It's basically something very interesting. So when objects interact with each other, they have different materials. So when two colliders touch each other, they have kind of different surfaces, right? So they can be very rough, they can be very smooth. And here we have default smoothness, which causes a little bit of friction in between them. So what we should do, I already created that before. Let me delete it so it's very clear what to do. You need to create a new material, so 2D, physics material 2D. Let's call it smooth. And then you see over here we have a friction. Let's change that to 0. And then on our player rigid body and collider, we can just, whoops, no, I need the particular properties over here. So over here and over here, we can set it, and now that specific material will be used, and that should make it much smoother. You see, the issue is resolved. Just to let you know, there would be another issue later on when we jump and touch the wall, and the character would be sticking to the wall. I think I will show you later what I mean, because this is one of those pain points that you may often meet. Even when working with AI tools, it will write beautiful code, but then you will have some problems because of incorrect setup. So I will show you that regardless of what we've done now. Okay, so we have nice movement to the sides. Of course, now we need jumping. Jumping will be pretty straightforward. So the first thing we have to do is obviously create some new properties. So header, and now jump settings, and now the first one will be private, float, and now we're going to do it slightly differently because there are two usual ways of doing jump, and one is the most common. So the first one is that you just create a property for a jump force or velocity and you use it, but this doesn't give you control over how high you will be jumping. This is working well, but you know, it's hard to adjust the values to find what you need. What we are doing instead, we'll be using jump height property, and we'll set it to 2.5. The reason for that is we'll want our jump to be 2.5 units high. So when we have a tile set, we will be 100% sure that the jump at the highest height will be above the two tiles that we want to jump on. So this is a very nice way of doing that. And this will, however, require using a physical formula, which is not that hard. I already kind of transformed it for what we need, and we can just use it. We don't have to worry about the details too much. So we have the jump height. Of course, for jump, we need another reference for the input. Whoops. Let's do that here. Beautiful. And now, of course, we need to react to that. So first of all, of course, we need to subscribe to the action. So action performed. And here we don't care for now if we leave it, right? So if we cancel the action. So for now, just performed will be enough, and handle jump input. And of course, we need the same thing for the on disable, just unsubscribing. Now, of course, we need a method for that. Whoops, no, we can just do even simpler will be that, and then jump. Beautiful. Okay, and you see it actually already nope, it's not correct. So let's write it from scratch. So first of all, on our rigid body, we need to set this time the linear velocity y. Okay, we have that. So the first thing we need to do is we need to get the value of actual gravity. So let's do that over here. Because when we use gravity, right, we have the global setting that we can find in settings. So if we go to project settings and the physics 2D, in general settings, we have somewhere here the gravity. Exactly over here, we have the default gravity. However, we have also a gravity scale on the rigid body itself. So if we would use hard-coded value, that wouldn't be correct. So first of all, we need to find the actual gravity. So for that, we use math f apps. That will give us absolute value, which is always positive regardless of what you pass. So you've seen there the value of the gravity was negative. But what will be, no, not this one. Sorry, that's the, here we need to convert the negative gravity that was in the settings and multiply it by the rigid body gravity scale. That gives us the real gravity that affects this particular game object. Now, for that, we need to use the square root, which is square root of what we're going to pass there, and that will be 2 times jump height times actual gravity. I don't want to bore you too much because this episode would take ages if I would like to explain you the formula behind it. It's really fairly simple and you should be able to very easily find resources regarding that. So it's enough if you look for the gravity formula or rather jump formulas for games, and you will find plenty of resources. If this is something you would like to know, let me know. I can create a short about it or something like that. That's of course something I can do for you. So this is, if I think correctly, again, first, this should be enough to have the first iteration of jump. So we should be able to jump. Of course, we need to first set the input action on our script. Over here, there is already jump action. So this is pretty straightforward. And yes, you see, we have 1 tile, second tile, and 2.5. 2.5 works. And over here we have 4, and of course we cannot jump on top of that. So everything correct here. Now, let me remove the material to show you the issue I talked about earlier. So you see, if I touch the wall and you see how slow I fall, this is because I'm not smooth enough for the wall to just fall down. So in order to prevent that, we of course need to use the smooth material, and now everything works as expected. Now we have another problem, which is we can jump indefinitely because we don't check if we are standing on the floor. Let's do that now. Again, we are going to do something slightly different than people usually do, because what usually happens, and the way you usually know it, people just create a game object, which they set here at the very bottom, but it has its own problems. Like, for example, if you change the size of the collider, or you do some other setup, then the ground check is in the wrong position, you have to scale it, then you have to worry, okay, is it close enough to the sides, or is it just a dot, should it be box cast or the sphere cast, and this type of stuff. So instead what we are going to do, we are going to use the dimensions of the collider to basically provide to do the correct size of the box cast. So let's do that now. Bool, and let's call it a ground check. Now we need to find the very bottom center of the collider. So bottom center, or rather collider bottom center. We need, of course, reference to the collider. It would be very hard to get something from it without it. So private collider 2D collider, and then in awake, of course, we get the reference again. We get the script, or rather component, from the object. Now over here, whoops, sorry, we need to get the collider. And nope, that will be vector 2, vector, new vector 2, because it's a 2 values, so one for x, one for y. And then we get first one from collider, then bounce center x. Is that correct? Yes, that will give us the central point in x. And then in collider bounce mean y. Yes, that will give us the lowest point in y. So that will be exactly what we need. And now we need to do, oh nice, return, but not physics 2D square, no square, box cast, yes. Now a call, that's incorrect. Exactly, we want the size, we want the full size. Let me just clean it up a little bit. We want the full size in x, maybe minus something very small, like 0.1, just so we don't detect the ground when we are standing next to the wall. The height of the box should be 0.1, and that should be enough actually. Then angle, we don't want it rotated, so that's perfect. Direction, okay, that shouldn't be box cast, that should be box overlap then. Is it overlap box? Yeah, this way. And that means we don't need the direction. Layer mask. So we need to tell the script what the ground actually is. So let's do that now. We need another reference. This time again in jump settings. So serialize field private layer mask ground layer. Okay, now let's set that, because there is one thing I need to tell you. There is we cannot set it now because there is an error in the script. So let me just do ground layer. Okay, now if we save it, over here you see, let's select the tile map. Over here you see I have layer, and I already selected the ground, but you are not going to have the ground when you start new project. So you need to go to add layer. I added it here because of the layer to the layer 3 because it's empty. You can add it anywhere, it doesn't matter. By the way, it's interesting that layer 3 is free. Do you know why, by the way? Because it's really always puzzling me why there are 3 here, then 1 empty, and then 2 another defined. So this is probably some legacy stuff. And now If we go back and select this one, it's very important, because if you add, you need now to select the correct layer, because if you add a new layer, your object won't automatically have that layer, because you can add multiple layers there and stuff. So just remember that after you add layer, you need to go here, select the layer. You select the ground. This is awesome. And now on our script, so if we select the player, we have to remember to set the ground layer to ground. And we can go back here. Yes, that will give us information if we are overlapping the ground or not. We can grab this. Do we do anything in update? Yes, we already do. So as a first thing, let's just check if we are grounded, and let's create a new field for that. Whoops. Awesome. So we store this information, and now when we jump, right, let's do that only for now if we are grounded. Then later on we'll have to change it to other conditions, but for now, if you, for example, wouldn't like any special behavior like double jumps and other stuff, this should be enough. Yay! Okay, so that solved the issue. Now, let's handle the animations, because our character looks a little bit boring standing like that. Very short break time. I would love to invite you to our new Discord server, fantastic game dev community. It's completely different than most of the servers that are there, because we are not focusing only on Unity, but we are focusing on game dev in general. This place aims to be a positive, non-toxic place, and I will really take deep care for it to be that way. We even have our own bot called Mashka, which can do pretty damn amazing stuff. So hopefully see you there. Okay, so when we select our player, let's move him a little bit here. Now we go to Window, Animation, Animation. This is the first thing we need to open to create our animations. Then, when we selected our player, now we have to click Create. So that will allow us to create a new animation for that particular object. Let's call it Humanoid Idle, save, and let's do something very simple. I don't know, we press the record button, because that will allow us to do any type of changes that we'll do basically in the inspector will be transformed into hotkeys, or rather the keys in the animation, and basically this is probably the simplest way to animate something. So at 30 seconds, let's lower the body a little bit. Then let's copy first and last frame. I press space to just preview what will happen. Okay, that's already pretty decent. Then I grab head, and I'm going to just rotate it. Maybe I will even type it like something like 1 degree, minus 1 degree. And then over here, I'm going to do 1 degree. Then I copy, paste at the end the same, so it will loop. So let's try it. So you see there is this small stop at the end. So it's basically because there is a little bit of, again, interpolation. So the values are not changing at the same rate. They are just following curves. So we can adjust that by selecting everything. Actually, if we open that, I think you could see the curves. Yes. So you see those are the curves, and you see they are not straight. So at the very end, it's just having some problems with that. So what we can do in the dope sheet, we can select all the keys and then change both tangents to linear. And now when we start the animation, you see the small stop is gone. So we have our small idle animation. Then we need walk animation. So create new animation, humanoid walk. Beautiful. For that, we can do also something simple. So let's start with the left leg over here, or maybe like that. Right leg over here, like that. Then at 15, we want them to be, or maybe just so it's easier to make them, let's move the legs inside. So obviously will be like walking movement. Whoa. Then let's copy first frame and put it over here. So it will give us a little bit of leg movement first. Then we'll need that twice. So let's copy that, go back over here. Or maybe before we do that, let's also change the positions. So for the body, we want just a little bit down, like something very ridiculously small. And over here, at the first frame, we may want a little bit higher, actually even with legs. So let me grab this, change to global, because you see the arrow would then follow the rotation of the object. So over this, that's okay. Here I need to fix the legs to be lower. So that should be, yep, all right. Then I copy this over here. And then I want that twice, because I will want some head movement. So you see that will be already something. It's too slow, so it looks strange. But most importantly, we need to do something about the head. So for the head, for this one, let's move it forward, like 3 degrees maybe, or -3. And then over here, let's do it 3. Then of course, at the end, we need the same frames. Let's see how it looks like. Much better. And then we are going to do both tangent linear. No, that looks much worse, because you see it looks too robotic, like it's too constant. So we are maybe just doing the, let me do that, whoops, light died. I hope it's not too problematic, that you still can see me. So I select those ones. And for head, I do just the linear, exactly. So you see the rest of the body has still the same tangents as it had, so it looks pretty decent. Nice. Okay, but it's very, very slow. So let me move that even like something, maybe 45. No, that's too fast. Maybe 1 second. Yeah, that looks pretty decent. Okay. Now we have the 2 animations. Now let's go to the animator, and over here we have to tell the animator when to display which animation. So like we have to set the conditions. So over here, let's create a first Boolean parameter. Let's call it is walking. Now, when we are idle, let's make transition. But our character is walking, we want to go to walk, and then the other way around. So if we are walking and our character is not walking, we want to go back to idle. Now there are some settings which I'm not going to go through here, because the tutorial would really take ages. I do have tutorial about that over here, so you can have a look. But what we need to do, in order for the animations to change smoothly, we need to disable the has exit time. And then for the fixed duration, we can set something like 0.1. Let me check if that does it for both. No, it doesn't. So over here, 0.1. We have the walking, yes, and now we need to handle that in code. But instead of doing that in the main script, let's create a new script for that. So, new script, platform movement animations. Let's move it to the, like remove it from the default namespace. It has to inherit from mono behavior, because we want to attach it to the game object. Now we need some references. So the most important one, of course, first one is the animator, because that is what will allow us to set the animations. Then, of course, we need information from our platform movement. We need to get those ones, so void awake, and actually this code is correct. So we want to get references to the component in the awake method. Now, our platform movement isn't telling anyway how it is moving, right? So we need also to expose an event when the input for walking changes. This will be pretty simple if you watch my event videos, so you definitely should go and check that. For now, let's just create that event. So it will be public. It will be action of type vector2 because we want to give to the other script the value of vector2, and then we call it on move input change. When we want to call it, of course, when the input changes. So handle walk input over here. So after we get the value, we want to invoke the event with the new value for the move input. We go over here, and over here in the update, we want to set on the animator the boolean, so set bool is walking to the value of platform movement dot, and was it, no, sorry, it is not on the update. We want to subscribe to the event, so we want to do platform event on move input change, and we need so we need to do that on the event, so on private void on enable, and of course we need private void on disable to unsubscribe. Now we need the event, so on input change, and something over here, so on movement on or handle move input change, and then of course we unsubscribe on disable. We create this method. Over here we can call it move input, and here on the animator we want to set our new bool that we created is moving to the move input x different than 0. So if it is different than 0, then it means we have some input and the character will be moving. If the input in x is 0, that means we don't press the buttons A or D, so we don't move to the side, so we shouldn't be displaying moving animation. Now let's cache this one, so let's use cached property index. This basically uses some optimization to do not use the string all the time, but rather an int, which is a ID of that particular property that we created, not property, but the parameter. Now we of course need to add our script to the game object. And that should be all we need to do. Let me just check on the platform movement if we have any new references. Nope. How did we call it? Did I make a typo? Here is walking, which is correct. Is walking false, is walking true, that is correct. And over here is moving, of course. It should be is walking. Oh no, we moved the... So I need to go back to the animation. Actually, I need to first reset the rotation of those ones to 0. And I need to check, because probably what happened when I created the animations, for this one it's correct. Maybe I didn't have the record button pressed. So if you don't have it pressed, what will happen if you change something? Obviously you change it in the scene. Nope, that works though. So I don't know what happened. Let me just save it and let's run the game. Yay, we have the movement. Even the speed of animation is pretty decent. Now we need to rotate our character to the right direction. We go back to the platform movement animations, and we already have information about movement X, or rather movement X. So over here, if the move input X is not 0, so if we press a button, then we want to change the X of the local scale. So transform local scale. I think it will be even easier to do this way. So var local scale, transform local scale, then local scale X, and math sign gives us 1 or -1 depending if the value is positive or 0 or negative. But because we are doing it only when it's not 0, then we'll get 1 when we press right, and we'll get -1 when we press left. So this is basically what math sign does. It gives you the plus or minus depending if the value is positive or negative, positive or 0. That's, crazy. Then we have the transform local scale, and we of course use the new local scale. Why I didn't set just the local scale X and then Y and Z to 1? Because this way I would modify it in case it's different, right? So if, for example, my character over here would have 0.5, 0.5, 0.5, if I would say it 1, 1, that would change the original values this way. With what I've done, I modify only X, Y, and Z stays exactly the same as it was before. So let's test it. Awesome. Okay, we need to add something for jumping. Plus also, I don't like this very floaty jumps. What I'm going to do, I'm going to go to rigid body and change the gravity scale to 1.5. And because of the way we wrote the script, we don't have to adjust the vertical velocity or anything like jump velocity. You see, it's still 2.5 because we calculate that dynamically. So this is awesome. Beautiful. Okay, let's add simple frame for the jump and frame for the falling. So when we go back to the animation, we can add humanoid jump. And for this one, let's just press record button and move the head up a little bit, and the legs rotate a little bit to the back. Awesome. And for the humanoid fall, let's just rotate the head a little bit down. Yep. Control Z, and then with the red button pressed. Okay, that will do it. Now in the animator, we need to set it up correctly. So that will be a little bit more complex. So for the parameters, we need a float value because we need to know what's the current velocity. So velocity Y, let's call it. And then we need to know if the object is grounded or not. So Boolean is grounded. Now, if we are not grounded, we want to be jumping or falling. Why both? Because sometimes we'll be walking off the platform. Because sometimes we'll be walking off the platform and then we skip the jump animation, we go directly to fall. So over here, from the idle, we want, when the character is not grounded, so for both, to jump and to fall, so actually for all four. If the character is not grounded, and then if the Y velocity is larger than 0, we want to jump. And if it's smaller than 0, we want it to be falling. So also here we have to disable everywhere D has exit time. And then make it change much faster. And then of course we need the transitions from jump to fall. So we don't need actually one from fall to jump. Do we? We need, because when we'll have double jump, we'll be falling and then we'll want to go up. So over here we do those ones if we are not grounded. So the same. And what's important over here, from fall to jump, we go when the velocity is greater than 0, and here when the velocity is less than 0. Now we need to go back to idle. Now we could do both, so we could from all of them go back to humanoid walk and humanoid idle, but that would be a lot of connections, and sometimes the changes between states are so quick that you won't notice any problems, or nothing will look ugly. So what I'm going to try to do is to decrease the number of connections by making transition directly to not walk, but to idle. And we'll see how it looks like, and maybe it will be okay. So over here 0, 1, over here no exit time and 0.01, and now condition is grounded true, and over here the same is grounded true. Now we have set up the animator, we also need to set up the script. First of all, we need to expose also is grounded. So public boolean is grounded. Let's do the capital I over here. And do we need a velocity? No, we'll have it from the directly from the rigid body. So what we can do here, what happened here with the formatting? Yeah, let me fix that. What we can do also private rigid body to the rigid body. Here of course we need a reference, and in the handle movement input change, is it over here? Let me think. No, we need that in update. So private void update for animator set float velocity y. We need the rigid body linear velocity y. For the boolean is grounded, we need is grounded. However, we want to cache those ones. Again, a little bit of performance optimization. Save. And this should be actually everything we need to have nice animations. Let me check that. Nice. And when falling, we should also have fall. Nice. And what will happen? I shouldn't be able to jump. Nice. I'm not able to jump. So everything works as expected. Beautiful. Okay, so it's time to add double jump. This one will be pretty straightforward. So we go back to the platform movement, and in the jump settings, we need a new property, or rather serialized field of type int. We want to know how many jumps we can make at max. So here we'll name it number of jumps 2. Then we need a property to know how many we have left. When we jump, so let's see where's the jumping. Over here. So when we jump, now instead of just checking is grounded, we need to also check if jumps left is larger than 1. We need to check when it's larger than 1, because what will happen, we'll still jump and then it will be 0, right? So it is a little bit unintuitive, but the correct value at this moment is 1. It will become 0 later, but at this moment it is 1. Now let's move this one to a new jump method. Private void jump. That will be a little bit cleaner. And at the end of the jump, we want to decrease the number of jumps left. Now, the important thing is, once we touch the ground, we need to reset the number so we can once again jump as many times as we could before. So, where do we have where would be the best place to put it? I think we could create a new method, void, and let's call it reset jumps, and then we just set the jumps left to the number of jumps, and then if we are grounded, then we reset jumps. I just prefer to have the braces around, so let's do that. And you may not believe, but that's actually everything we need to do. Now we just enter, okay, we have already 2 jumps enabled. 1, So let's debug what is happening. Let's change the mode to debug. We see 2 jumps left. Okay, it's not decreasing. Oh, because I know. We probably did the condition and. Yes, it has to be or. And then, yeah, that's what's troublesome, is that it didn't decrease the number of jumps. So let me have a look once again. Okay. Yes, now it works. Oh, I see the problem. So it's not, it should be actually 0 there. But you see, when we jump, it still detects the first. So you see what is happening. When we are going up, the number of jumps stays still because it detects it as still as grounded. So when is grounded, should be, maybe, let's see what will happen if we add an extra condition. If rigid body linear velocity y is larger or equal to 0. That means if we are moving up this way, it checks is grounded only when we are actually going down or standing. No, actually when we are going down. So this is incorrect. Yeah, this should be only when it's larger. Let me have a look what will happen. It's not. Actually, it shouldn't be here because is grounded should actually check if we are on the ground. So disregard that for a moment. Yep. Crazy things happening. Exactly. It shouldn't at all be here because is grounded should only check if it is grounded, not if we are moving in another direction. So over here, we should check if it's grounded and the rigid body linear velocity is smaller or equal to 0. Velocity y. And I believe this should be then 0. No, this is the wrong place for the condition. It's about resetting. So the condition should be to reset jumps if it's grounded and the linear velocity is larger or equal to 0. This way we reset jumps only at that condition. Yes, and now you see everything works as expected. So when we jump first time, it's not resetted and everything works as expected. Beautiful. So we have nice double jump. Now let's add control linear. So basically at this moment, when we change direction while walking, we can change the direction at the same speed while we are jumping. And sometimes we would like the control in the air to be much smaller. So if we jump, we kind of have to commit it to that jump. We have to commit to that jump already. So let's implement that now. So we go back to the jump settings. Over here, let's do private, float, and then in air control, and let's say that we want a 30% of the control in air. Now the fix is pretty simple. We can copy this value and then we go to the place where we apply the where we lerp the walking speed. So in the handle walking, what we do, we create a new variable called control. And if we are on ground, exactly like here, if we are grounded, we have the full control. If not, we use the setting provided in the field. So here we just multiply it by the value, by that value, and everything should be working fine. Let's check it. We move to the sides, we change the direction pretty smoothly. When I jump, whoa, it's much harder to change the direction. Exactly what we wanted. Now let's add one more improvement to the jump. When we release the jump key, we would like to suddenly go back or like go down, like for example in Hollow Knight. Okay, so over here we go to the top, and in the jump settings we set serialize field, float, and then jump cancel divider, and let's start with 2. We'll see how it works. And now we need information about when the jump was cancelled. So over here we have to subscribe also to that information. But first let's create a method for that. Beautiful. And now when we cancel, we basically do the rigid body if, maybe like that, if the rigid body velocity, linear velocity y, is larger than 0, that means we are going up. Let's set the linear blah 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 linear. Let's set the linear velocity y, or rather let's divide it by the jump cancel divider. And now we just have to over here and over here subscribe to the right event, so to the jump action cancel. And again, this should be all we need to do. Now everything working as expected. Now I release the button and looks beautiful. Awesome. And full jump and a little bit. Yay, awesome. Okay, so the next feature will be wall sliding. For that, we need another raycast. So basically we are already checking where the ground is. Now we need somewhere here in the center of the site, check if we are touching the wall. So over here, let's write another method, private bool wall check. And now we need, let me think, collider side center. collider side center, new vector 2. And this one differs a little bit because we need different side depending if we are on the which way we are rotated. So maybe for that let's do var side position, and we can do collider bounds either min or max, right? That will give us left or right. And now if the transform local scale x is larger than, no, smaller than 0, then we want the minimal, otherwise we want the maximal. Min, max, x, sorry, this should be yes. So we either need the minimal x, so on the left, or maximal x on the right. So this gives us side position. And then for the center position, it's very simple. We just do collider bounds and center y, and we have the correct position. And now we need to return physics 2D, and for this one we can do a just simple circle overlap. So collider side center, for now let's just do that, and also on the ground. And this way we know if we are if we are next to the wall or not. Now let's add some settings. Wall slide settings. First of all, we may want to know what is the maximal fall speed in general when we fall. So private float default wall, or rather default fall max velocity. Let's set it to something like 15. Then let's create another one for the wall slide. So this one is the very slow one. Wall slide velocity, and that might be something like 1f. Awesome. We have those two. Let me think now. Okay. Let's handle that now. So under our update, let's create private void handle wall slide. If we are next to the wall and our velocity, so if our RB linear velocity y is smaller than 0, so we are going down, then we want the RB velocity to be set to, then that's tricky, so math f, and we want the smaller, the larger of 2. So we either want the RB velocity, linear velocity y, and of course here we also are setting velocity y, or we want the slide velocity, and of course we need to calculate that. So we can actually move this one over here and do var slide velocity. If it's wall, exactly. If we are next to the wall, we slide slowly, otherwise we slide normally. We set it over here, everything is all right. And now we have to use this one in the update method. Whoops. Nope. Because it should be actually minus value for both of them. Because we want to go down, not up, right? Positive value go up, negative go down. So that also means that probably my condition over here, no, the condition is correct. Yes, so once I fall, I either use the normal value, normal fall velocity, which is correct, or when I'm next to the wall, I use the, and we have actually nice sliding down animation because of the fall, so side effect. But I see that I don't like the white collider, so let me just change the size a little bit, the size. And you see, because of how we wrote the cast for the ground check, I don't have to adjust anything. Much better. So we don't have to write any enabling or disabling for the double jump, because we can just set the number of jumps to 1. But for the wall slide, it would be good to have a enabling logic. So over here, let's add another field, this time of type boolean, and wall slide enabled, and by default let's set it to true. Okay, now we copy this and we wall slide. Where is the handle wall slide? So to use the wall slide, we have to be next to the wall, but also we have to have the wall slide enabled. So the fix is very simple. This is very minor change. Over here, then we slide over here. This one works. And now if we go back to the normal view and we disable the wall slide, we just fall down normally. So everything as expected. Let me just check if exactly, those change a little bit too slow. So I realized that we have the exit time left there. So now it will be changing much smoother, much quicker. Oh, nice. Maybe a little bit too fast, but so let me change the values to something like 0.2. And now it should be very smooth and very nice. Oh, much better. Nice. So our wall sliding works as expected. While we are on the subject on walls, probably would be good to implement now the wall jump. This one is a little bit trickier because there are many ways of implementing it. Normally, let me just start the game. When we are next to the wall and we press jump, right, we would apply some force outside. So we go there and the character does something like that, obviously much smoother. So because we are starting from 0 and we have the inner control, it's very hard to show. But basically, you know, the character would just jump out of the wall and would be able to grab another wall. To do that, we would disable the control for a while. So we wouldn't allow the player to modify that velocity. So if we are here, right, and because if we leave it as it is, even if I apply any velocity in the opposite direction, because I press the letter D to be next to the wall, I'm not going to jump this direction, right? So I'm going to stay by this wall. So normally we would have to disable the control for a while, but we have a special trick here which will allow us to do not do that, because we have the in-air control. So because our control in air is very low, we may actually get away without disabling the controls. So let me have a look how it will behave and if it will look all right. If not, then we'll add the disabling of the control. First of all, let's create a new section for the wall jump. Wall jump settings. Of course, first setting is we need to check if we even have the wall jump enabled. So wall jump enabled, and of course we have it set to true. Of course it has to be serialized. Then we need another serialized field. This time to set how strong the horizontal force should be. So float and horizontal velocity applied. And let's set it to something like maybe 7. We'll see how it works after, and we can always adjust it. So this is not a problem. Now, when we jump, so we need to look for our jump code. Actually, over here, we can check, because wall jump should be allowed regardless of how many jumps we have left, right? So let's just do wall jump enabled. And let's just check over here. Do we store it if we are next to the wall? Let me have a look. No, we don't. So let's do that. Is next to the wall. Wall check. Let's create a new field for that. Next to is grounded. And we already checked somewhere the wall check, right? This one not. Is this one in exactly over here, so we can just is next to the wall. Wall check, everything okay. So it's only one. Now we go back to our code in jumping. So if the wall jump is enabled and we are next to the wall, and of course this is very important. Now it's all good. And now the tricky part. So if we are, well, let's close it. We jump normally up, but then we want to apply also the horizontal force. So now, if we are not grounded, this is very important, because if we don't do that, we'll apply the horizontal force even when we are standing on the ground. So if we are not grounded, then rigid body velocity, linear velocity x, depending on the scale, again, we want the math f sign, because we want to know, are we rotated the left side or the right side? So we either will get plus or minus, but this time we have to reverse it, right? So if we are rotated right, the value will be 1, but we want the opposite direction, so we want to have minus there. Over that, and now horizontal velocity applied. And let me check, because I do believe this should be everything. Yay! You see, we have beautiful wall jump, and because and I'm holding the letter D all the time, so you see the inner control just prevents me from quickly changing the direction, and it allows, oh, I love the wall jump so much, it's so cool. Nice. Let me just, oh, look, I just got, because I need to be by the wall, and the force is applied when we are not. Oh, of course, not only when it's grounded, but also when I'm next to the wall. So this is very important. So let me check. Here works. Here we are not getting any strange force. If I'm here, no, exactly. Beautiful. So let's go over here. Let's see if we can use the, nice, works well. Beautiful, nice. Oh, and for this direction the force is perfect. So if I go here I need a little bit of input, but if I'm here I can just, what? No, it, nice, love it. Okay, so the wall jump works as expected. So now gliding. This one is fairly simple because we already have something similar. So gliding works similar to the wall sliding. It just works when we are not next to the wall, right? So over here we would have a slowdown, and basically we would probably have a constant speed applied, constant horizontal speed applied. And then obviously we need some time limit, so we basically stop gliding at a certain point. So let's do that now. First, let's create some properties again, or rather some fields. So header, gliding, settings, and serialize field. Of course, the first one will be private, Boolean gliding enabled. Then the second one will be gliding vertical velocity, or maybe just to make it shorter, gliding velocity y. Let's do 1. Now there are two ways of doing the gliding. We can disable, or we don't have to disable physics. If we disable physics, then the velocity will be exactly 1, or rather -1, because we'll be moving down. But we can keep the gravity, but then this value will be corrected by gravity. So this is very important, because you may get some unexpected behavior. We are not going to disable gravity. We are going to do that for dashing, which will be next. So you will get the idea. You can apply it also here if you need that, but I like the gravity to actually affect it, because if you change the gravity for some reasons in game, then this value will be also affected. So it's not me being lazy, it's actually I think a good design choice to have that affected by gravity. So we have gliding velocity y, and then serialize field private float gliding velocity x, and that could be, for example, 3, so a little bit slower than our regular move. Then we would like a gliding time. So how much time we can actually glide. So max gliding time, let's set it to maybe 3 seconds. And serialize field private float, and this is a tricky one, gliding trigger time. So because we'll be using a jump button, right? So we need to hold the jump button for a while and to activate it, and I think this is the best way to do that. Of course, you could do that with input actions, so you could set another interaction. You can set a hold there for a given time, etc., etc. But in case you are not too familiar with input actions or the new input system, I want to do that in code. So now let's go and create a new method, gliding. Oh no, did I create one for enabling gliding? Let me have a look. I created. Good. We need now to check if the jump button is pressed or not. For that, we can do private int, oh no, boolean, sorry, bool, is jump button pressed. For that, we can just check we can set it on the jump performed. So over here, we can set it to true, and on cancelled, we can set it to false. Pretty straightforward. Now we can use this value, private void handle gliding. So if, of course, gliding enabled, and is, do I have one for is gliding? No, another field we need. So private bool is gliding. So let's straight away create some more float gliding time left, and private float trigger gliding time left, or maybe just timer. Okay, that's right. Now, if gliding enabled and we are not gliding, and the gliding timer the trigger timer is smaller or larger than gliding trigger time. So basically, if we are not gliding, this should be, and gliding is enabled, and we are holding space for enough time, okay, and exactly, we are is jump button pressed, then what we should do, we should start gliding. So is gliding equals true. And of course, here probably we need to do some extra conditions. So exactly, we need to move this condition outside because we want start gliding only then, but we'll reuse this condition for something else. Over here, we want to also increase the gliding timer, the trigger. So we want to get this one, and we want to add to it time delta time. So basically we want this to increase as long as we are not gliding, we are pressing the button and the gliding is enabled, right? And only when those conditions are true and the gliding timer is more than it should be, then we are starting to glide. If we are gliding, then we need to set the vertical velocity. So rigid body, vertical, if we are gliding, and actually here, because to do not, if you remember, we are changing already the vertical velocity for some stuff. So over here, we want to be sure that we are going down. Only then we are changing the velocity. So if our rigid body linear velocity y is smaller than 0, so we are going down, then we want rigid body linear velocity to be mean, so mean max actually, so we want the higher one. We either use the RB linear velocity or we use the minus gliding velocity, so we move very slow down. Now we need to use this one inside of update. And let me check, because this is not all, because we want to also apply the vertical movement, we want to reset, we want to decrease the time, but for initial iteration of the gliding, this should be enough. Maybe let me just reset the timer. Gliding, maybe let's do that as well. So if we are here and we hold the button, yes, you see we slow down exactly as needed. So this looks like a little bit like parachute, so he should have nice small parachute over here. But what we'll be doing also, one thing that we need to add is the RB velocity, linear velocity x should be exactly his direction. So math sign, I explained it already 2 times, I think. So we get the direction from the scale and then we multiply it times the gliding velocity x to make sure that he's always moving with some value, because it's gliding, not parachuting, so he has to be moving in that direction. And then what's important, we need to also decrease the time he has to glide, that he can glide. So we have the gliding time left minus delta time, and then if his gliding time left, actually I think we can do it outside because we want to yeah, let's do it here. So if if gliding time is smaller than 0 or smaller or equal 0, or no, if it is, you're right, it should be actually here. So if the gliding time is smaller than 0, we stop gliding. And then once we hit the floor, we have jumping reset jumps, so we also should have reset glider. Private void reset glider, and for that we need time, gliding timer left, sorry, nope, gliding time left to max gliding time, and we do that when we hit the floor. Where was it? Over here. Yay! And you see he fall down because what's happening now? He's gliding. Okay, again we need to debug it, so we change to debug mode. And is he gliding? Yes, he is gliding. Why? Of course, because we don't stop gliding when we leave the button. So, first of all, we should make sure that the gliding happens only. So where's the gliding enabled? Is jump pressed? Yes, but if is jump button pressed? No. Or is grounded? Then we need to stop gliding. So is gliding false? And this should fix the issue. Nice. Let me check if we... and we need to disable the... And we need also to set here the timer. So gliding timer to 0. And now everything will be working as expected. Nice. Okay. So we have gliding, fantastic. Okay, fantastic people. So it turns out that I misrecorded a last 45 minutes of the recording. So in case there is something strange in the code, please bear with me. I am going to provide a link to a GitHub repository with all the code, maybe even improved. So I want to make sure that you have a version that works. I think I removed everything I wrote during that time, but there is a chance something went wrong and just wanted to make sure that you know what happened. Everything should be fine. So first thing is we have our gliding, but our gliding looks pretty boring. So let's add first animation to it. We go to Window, Animation, Animation with our player selected. And of course, we create a new clip. So clip, we save it in the animations, humanoid, and this time it will be gliding. This one will be one of the simpler ones, like fall and jump. So first thing, I'm going to rotate the body. Beautiful. Then rotate his head the other way around, like that. And then we need to do something about the legs. Let's first rotate them like that. And then make sure it's set to local, then it will be a little bit easier to move them because the arrows will be in their rotation. And of course I had to misclick it. Now right leg again, record. No. Okay, player, record. No title, no. Gliding, no. Grab right leg and move it over here. And actually, I think I'm going to even rotate it a little bit more. Nice. So I have the animation, but there is one more thing I want to add. So on the player, I'm going to add the trail renderer. If we move the character already, you see something is going to follow it. Follow him, and I'm going to make it a little bit nicer. So first of all, we need to get rid of the pink color, which means there is a problem with material. And in this case, as you see here, there is no material whatsoever, so that's the problem. I click over here, select the default line, and already we have nice white color. Now 5 seconds for it full time, it's a little bit too long, so I'm going to do something like half a second. This is I think it's still quite a lot, so but let's leave it for now. Then I'm going to add a key here, and I'm going to modify its width. So I'm going to make it start with like 0.4 and then go completely to 0. So it will look something like that. This is pretty decent, I think. So do I need to change anything else over here? No, I don't think so. Maybe I will just disable casting shadows. Now let me see how it looks. I know it will be always following the player, not for dashing only, so not dashing gliding, so let's check that. Yeah, that looks pretty nice. Let me check if I have the gliding enabled. I do. So if I try to glide, yeah, very nice. So let's now apply the animation. So first of all, we need to notify the animator that we are gliding. So for that, let's create is gliding property, which will just give back is gliding. In the platform movement animations, we need two things. First one will be the trial renderer reference. So trial renderer, okay. And now we want it in awake methods. Okay, so we have it. Because we'll be using it also for dash, I'm going to create a property, and that will be Boolean. Let's call it should trial be visible, and for that we can do platform movement and then is gliding for now. And then in the update on the trial renderer will be emitting only if the trial should be visible. Pretty straightforward. Now we also need to add information to the animator. So set bool is gliding platform movement is gliding. Of course, we cache it as before, so we save it. Now we have that over here, but we also need to handle that in the animator itself. So we go back to the animator, create new Boolean property is gliding, nice, and now, and now what we can do, we can connect only the humanoid fall to gliding, and then from gliding to idle. That's because we first have to be falling in order to start the gliding. So this is the only state from which we'll be starting gliding. And then, like with other animations, the idle is pretty short and the transitions are short, so you won't even notice that, you know, that we went through idle. But on the other hand, we'll avoid a big spaghetti over here. So I think it's a nice compromise. First, we disable has exit time on buff, we change it to 0.1, and over here also 0.1. We add here first is gliding, of course true, and then over here is gliding false. Now, of course, we go to idle only if we are standing on the floor, so grounded true, and we go back to fall again without exit time and within 1/10 of a second if we are not gliding anymore and we are not standing on the floor. So now it should be working. Let's save it. Well, I already started to glide, so you see, awesome. Nice. Awesome. Okay, so gliding works as expected. Now it's time to add something called Coyote Time. The Coyote Time is very simple concept. Basically, you see when we are off the platform, like for example over here we have very like large gap, and for some it might be already precision jumping, right? So it might be pretty difficult for them, and we would like to avoid that, right? Oh, for example, now I didn't jump through, and for some people that might be annoying. So what happens usually, we give them some extra time after they fall from the platform to actually make the jump. So we don't, you see this is happening because we have double jump, so we can pretend that this is what's happening, but basically, you know, they would have they would normally, without the Coyote Time, if they go from if they leave already the platform, they cannot jump. If we give them Coyote Time, like for example 2/10 of a second, they have this extra moment to react and save themselves. So I think this is something very nice to add. Let's do it now. First, we need to go back to platform movement, and in the jump settings, add one extra serialized field. We'll call it Coyote Time. Nice. Now we have to store somewhere the timer. So if we still have this Coyote Time or not. Beautiful. Okay, and now we of course need to update it and reset it when needed. So first we can reset it. And for that, we simply do the timer equals 0, because we'll be starting with 0 and we'll be adding time over there. And that's the reset is very simple because we reset it together with everything else. Now when it comes to increasing it, we do it in a new method. So update Coyote Time. And now, exactly, we just add the delta time. Now, probably would be good to have a condition. So first, we do it when we are not on the floor. So when we are not grounded, and when the time still hasn't passed. So when the Coyote timer is smaller than Coyote time. Now, because we'll be checking this multiple times, let me create a property for that. And let's do that. And let's use it over here. So we only check it if the time hasn't yet passed. Now we update it over here. And in our handle jump input, now we of course have to modify the conditions. Now instead of the check if we are grounded, we simply check if the Coyote time hasn't passed yet. However, there is one more bug which we have and which we have to address now. Let's have a look at it. So when we jump, let's focus on the player so we see the inspector. Let's change to the debug mode and let's have a look at the jumps left. So when I fall from the platform, regardless of what's the value of the Coyote time, I see that it's not updating as expected, so I will have to have a look in a second. But when we fall from the platform, we still have 2 jumps, and we should have 1 less than we started with, right? So we have to address that now as well. So we have to decrease, we can call it like late jump decrease. So for example, when we fall from the platform, we'll be decreasing this one by 1. So let's do that now, but first let's check what's happening with the Coyote timer. Let's check our condition. So if we are not grounded, we call it, yes, that's correct. And if the Coyote time hasn't passed yet, we change the Coyote timer. Is the condition correct? The Coyote time passed? No, that's incorrect. That should be reversed. So if the Coyote timer is larger than Coyote time, that means it has passed. Let's try it now. Yes. And when we land, it resets everything as expected. Now for the late jump, let's do it under the update method. Over here we can create a method private void late jump decrease. So of course we need to decrease jumps, so jumps left minus minus, but what would be the condition? First of all, we have to make sure that it's only first jump, right? So we need to make sure that the jumps left is exactly the same as the number of jumps, and then that the timer Coyote time has passed. So only when we are too late for the first jump, we remove it from the list, or not from the list, but from the counter. And maybe we can move that over here so they are together, and this should address the issue. So if we change just to one jump, I should be able to jump all the time normally, like nothing happens. Good. Here there's something strange, but we need to not relate it to our change. Okay, but now, whoops, let me also disable wall slide because I think they are okay. And now if I fall, yes, I see after a certain time I cannot jump anymore. So if I do it very fast I can jump, but if I'm falling for a while I can jump, and that means we fix the bug and that we introduce the Coyote time as expected. Awesome. Fantastic. Now it's time to add probably the most exciting part, which is dashing. For that we need completely new section. So over here, whoops, not here. Over here we do new header and we call it dash settings. We create first serialized fields, and of course if we check if the dash is enabled or not, then we need to have the dash speed. Let's call it dash velocity to be consistent, and let's do it like 12. When I tested 10, it was a little bit too light. So then we need the dash time, so float dash duration. I think 0.4 will work nice. And let me think if that's everything. No, for now I think that will be everything. However, whoops, we need to know if we are jumping, if we are dashing currently. We need to know if we can dash. So that should be all good. Now, can dash should start as true, because that's what we do. We want to be able to dash from the very beginning. So we need to add the ability to reset dash. So private void reset dash. Now can dash should be true, and of course we reset it as with everything else when we hit the floor. However, to initiate the dash we need another input reference. So at the very top, whoops, we have some strange stuff. At the very top over here we add one more reference. Oh, it already predicted I want to add that, so dash action. And of course we need to subscribe to it and unsubscribe. So over here, dash action and handle dash input. Over here, minus, beautiful. Private void handle dash input. And over here, which will move down in a moment, and dash. First, we need to know if we can dash, right? So we should have the dash, we should be able to dash, then we should have dash enabled. And most importantly, we definitely shouldn't be dashing, right? I don't know what's that, sorry. Then we start dash, but the dash should be coroutine because we need to do certain stuff after time. So I enumerator. And we need a reference for that. Lovely. So we'll be starting the coroutine for dash. However, we need to know in which direction we'll be dashing. So we want to store at this very moment the input the player was pressing. So direction will be the move input normalized. We pass it to dash, and of course because of that we need a new parameter. Over here, first we say that we are dashing. You cannot jump at this moment. Ooh. Oh, it actually, I think it gave us everything. So we definitely need to set the velocity. However, it will be the linear velocity to the direction times dash velocity. That's correct. We need to wait until the dash finishes. And then we say we finished dashing. So it should be that. We enable can dash when you stand on the ground. So this is not a good place for that. And that might be actually it. Let me have a look if that works. Of course, we need a new reference input. We need new input action reference. I already had it added, so let me remove it. In the actions, you of course just press the plus button. We can call it dash, and for me, I'm going to connect it to the F button. Save, and then I need to add it on the script. We need to be out of the debug mode, and the dash is over here. So if I start now and press F, I see I dash very nicely. However, after I finish dashing, I preserve the velocity, so I'm going very far. We need to do one more thing there. Because this might be what you like. So if this is what you want, you can leave it like that. But what I'm going to do, I'm going to do the linear velocity vector to 0. And this will stop any movement so that when the dash finishes, I will be literally standing where like the movement of the dash will stop. So you can check it now. You can check it now. You see? So basically I'm not flying further as I did. It just finishes over here. I just need to check. No, I cannot dash multiple times, so that's okay. I can dash on the floor, so everything is working as expected. Now we only need to enable the trial. To do that, we can create another public property. And we can use it over here just to say the should trail be visible. So is gliding or platform movement is dashing. Yay! Oh, that looks super cool. Okay, so we have everything enabled, double jump. Let's see how nice is it to traverse all the levels. So with the wall jumps, we can do some crazy stuff. Nice. We can use the dash, wall jumps to do crazy stuff. Let me just try that. Dot. Nice. Bah. Nice. Oh wow. I didn't design it thinking about it, but worked well. Wow. I'm not used to this movement, so nice. This is what I wanted to do. Very nice. And gliding. Whee! Whew. It was a very long tutorial, but I hope it was worth your time and that you found it useful. If so, please leave a comment, visit our Discord server, and if you'd like to support me personally, you can have a look at my game Happy Worker Tool Company, which is already released on Steam. It's just, I think, under $6, so if you could buy it, that would help me a lot, it would help grow this channel. And meanwhile, have a fantastic day, love you, and bye bye.